For the longest time, we've thought of AI as this brain in the cloud, right? Pure code, pure thought. But what happens when that mind gets a body? When it gets hands and feet and starts moving around in our world? Well, that's exactly what we're breaking down right now.
The next huge leap for AI isn't really about writing a better poem or making a prettier picture. No, it's all about getting a body. We're talking about the moment AI transitions from just being a digital mind to becoming a physical presence. It's about grabbing things, walking through our spaces, and learning from the real, messy physical world.
And look, this isn't some far-off sci-fi movie stuff. This is happening, like, right now. You're already seeing the early days of it. Every time a little delivery robot rolls down the sidewalk, or you see an autonomous car navigating traffic. AI is no longer just stuck behind a screen. It's out here with us.
So, as AI starts getting a body, two terms have popped up that are super important to get our heads around if we want to know where this is all going. Those terms are physical AI and embodied AI. They sound pretty similar, right? But the difference between them? Oh, it's huge.
Okay, so let's start with the big, broad category, physical AI. This is basically any AI that has a physical body, something you can touch. I mean, think about a robotic arm in a factory, perfectly grabbing things over and over. Or, a drone that swerves to miss a tree. The big idea here is simple. It's an AI controlling a real physical thing.
Now, here's where things get really interesting. Embodied AI is a type of physical AI, but there's a giant difference. This isn't just about following a pre-written program. It actually learns from trial and error. It shapes its own intelligence by physically interacting with the world, kind of like how a toddler figures out how to walk.
Yeah, and this slide really breaks it down perfectly. On one side, you've got physical AI. It's all about having the form, the body. It does what it's told based on its training. But then you have embodied AI, and that's all about the experience. That robot dog, it learns to walk on a rocky path by actually trying it, stumbling, and figuring it out. It's not just in a body, it's using its body to get smarter.
Here's a super simple way to think about it. Physical AI is the parent, but embodied AI is the child. It learns by moving, by bumping into the coffee table, and just figuring stuff out. So remember, every embodied AI is a physical AI, but not the other way around. Not every robot with a body is actually learning from its body.
Okay, so who's actually building all this cool stuff? You're probably picturing these giant, secretive labs at huge tech companies, right? Well, that's not really the whole story anymore. The tools to build and experiment with this stuff are actually becoming available to just about everyone.
Check this out. This is basically the modern robot builder's toolkit, and the amazing part? It's pretty much all open source. You've got ROS, which is like the operating system, the software backbone. Then you've got Arduino and Raspberry Pi, these tiny, cheap, but super powerful little computers that act as the brains. And of course, OpenCV. This is the magic that gives the robot its eyes, its computer vision.
So why is this open source thing such a game changer? Well, for one, it makes learning this stuff accessible to everyone, not just people at fancy research labs. Then, you get this amazing global community sharing code, solving problems together, which just makes everything move faster. And that leads to crazy fast innovation, because nobody has to reinvent the wheel. You just build on what others have already done.
All right, so the tools are getting easier to use, but some of the problems, they are still insanely hard. And maybe the hardest problem of them all is just getting a humanoid robot to walk and balance on two legs like we do.
We don't even think about it, but our ability to just stand up and walk around it's a biological masterpiece. For a two-legged robot, just standing still without falling over is a massive, massive achievement. It's like constantly trying to balance a pencil on its tip, nonstop.
So how in the world do they pull it off? Well, a huge part of the secret sauce is this concept called the zero moment point, or ZMP for short. Basically, it's the one spot on the ground where all the forces, gravity, momentum, all of it, are perfectly balanced so the robot doesn't tip. The robot's brain has to calculate and recalculate this point constantly, shifting its weight to keep that point right under its feet. It's this high-stakes balancing act happening many times a second.
And if you're wondering just how deep this rabbit hole goes, these are actual topics from a graduate-level robotics course. So yeah, it's not just about making it walk. It's about recovering from a push, planning how to use hands and feet to stay stable, and walking on bumpy ground. Each one of these is a huge research area on its own.
But here's the crazy part. Even with all these massive challenges, the world of humanoid robotics is just exploding. The amount of progress and research happening right now is just mind-blown. Want some perspective on that? In just the last year, we've seen more than 100 new research papers published specifically on humanoid learning. Think about that. This isn't some slow-moving field. It's a full-on wildfire of new ideas.
And just look at the titles of these papers. They're not playing it safe. They're going for things like making robots not just stable, but truly agile, using all sorts of data to make them move in more versatile ways.
They're literally teaching robots to embrace collisions. Instead of just avoiding bumping into things, they're learning from contact. And that's absolutely essential for operating in our messy, unpredictable world.
And then you get stuff like Kung Fu Bot, where they're teaching them super dynamic, whole-body skills. I mean, come on. This is the absolute bleeding edge of robotics research, and it's just getting faster every single day.
And what all this creates is this incredible, powerful feedback loop. You see, better, more agile hardware lets researchers try crazier AI ideas. And that new research immediately creates a demand for even better hardware. It's a cycle that's just spinning faster and faster, pushing the whole field forward.
So this all brings us right back to where we started. AI is getting a body. And maybe even more importantly, it's learning from physical experience, just like we do. So as these robots get smarter, more capable, and start walking among us, you have to wonder, how is that going to change, well, everything?